Hello, welcome to another video. I haven't made a video in a while because I was trying to work on this project here. Let me try to find it. I think this is the last one last version I made. Pong. You know Pong. Pong is such a great game, but it wasn't very great for me when I tried to make it. So let me try to demonstrate how this was failing. Don't worry if you don't understand any of this. You shouldn't actually. But anyway, so that it's moving, but then it freaks out. I don't know why. It's annoying. It's I tried to fix it. Been working on it for 3 weeks. I don't know. So because of that, I need to put out a video. Both because I kind of feel like a responsibility to do so, and also because I don't want YouTube to think I am dead. So let's do this. I made a random input generator kind of thing. So if I press the button, it puts an input out. So 1 of 4. So it did the same one again. It did that one this time. That one. That one. That one. So yeah, it's pretty random. So I'll just explain every part of this. So first, this is gonna be a kind of short video, so just stick with me, okay? It's a pretty short video. Just explaining this thing I made. So first, this button goes into here, which is just a normal gate. This isn't really necessary. I can just delete these and put these like this. So this is something really interesting, actually. So if we go over here, I have this little thing that I like to call a limiter. It's just basically an XOR gate, a timer with the amount of time you want the pulse to be, and an AND gate. So you hook the timer to the XOR and the XOR to the and then you get this fun thing that just limits the amount of time that you the pulse is shown or given, you know. So I'm just gonna hold the button and it just gives that little bit. I release it, nothing happens. So that's basically it. And what I did with this was, instead of having a timer, I chose to just have a normal logic gate. And my idea with this was that since when you put a signal to a logic gate, it's going to slow it down by a tick. So you send the signal, it goes to the logic gate, and then a tick later, it sends the signal from this logic gate here. A really good way of showing this is to do this here. You'll see that it takes a little bit of time for it to get all the way to the end. So that's basically what I did. Somewhat. So instead of using a timer, I used a simple logic gate, which means that it only broadcasts a signal thing. What am I using? It only outputs a signal for 1 tick. So that goes into here. So I kind of have to explain this first. So I have to reset this for the first part. So you see that no signals are going through here, so something that has to happen. So first, I take a button that hooks up to one of my limiters. This time it's a timer, so it can give 3 ticks of pulse length, and it goes into here immediately. Then 3 ticks later it goes into there. 3 ticks later it goes into there. 3 ticks later it goes into there. And then these are 2 timers hooked up into each other. This doesn't matter really. So 2 timers hooked up into each other. They're both 6 ticks. So that means that in total there are 12. And I have one of them hooked up to go into something else. Well, we won't get into that yet. So if you can do some math here, and you know that this goes into that immediately, then this goes into 3 seconds, and this is 6 seconds later. That's 9 seconds later. and this is 36 length, then you can probably understand that at all points there's going to be a signal going out of one of these, and it's just going to be oh, these loop, by the way. So since they're attached to each other, they loop. So there's always going to be a signal going out of one of these, and I can show you that by pressing the button. My dog is walking in the background, but look, it kind of just like there's always a signal going out of one. And if I think if I unless Scrap Mechanic decides to do something weird, if I hook these all up into each other and do an OR gate, then it's about always on. If it's not on all the time, then it's not. It's just because of Scrap Mechanic engine. Hello, dog. Anyways, these hook into there, and we loop back to this thing. So if this button is on, it goes into. My dog is being very loud in the background. I'm sorry if you hear that. These go into, okay, so each one of these goes into basically a logic gate. These right here are just to show me if these are on. That's it basically. If they're on, then it blinks. That's just for ease of use on making it. I can actually just break those. Anyways, these go into these logic gates. So each one of these goes into one of those, and this goes into there as well, meaning that when you press the button, it if one of these are on, which one of them will be on, it will light up. And these each go into their own one of these things, which I will explain right now, because they're pretty neat. So I made this thing a while back when I faced a conundrum in my 2D platformer video. So basically, the problem is you have a really short post length, which is necessary for this, because we only want this to, like, if it's long enough, then it's going to make it be very highly probable. If the post length is high enough, then it's gonna make it highly probable that it's going to make more than one of these be on, which is not going to be good. Anyways, so we want a very short post length there. If you have a really short post length, then you put it into a logic gate contraption kind of thing, like a computer. At least how I like to build stuff, it could freak it out a lot. Well, at least in Scrap Mechanic, that's the thing. So here's a NOR latch. Basically, I think that's what it's called. Basically, you click one, and it switches. So like if I have this one, it will switch to that, and I have this, it will switch to that. I press it again, nothing happens. Basically, it's the fundamental way computers store information. That's pretty cool, right? Anyways, I have a really short post length, and I put it into the this thing. It could just freak it out like that and break the whole thing, which is not fun. So what I did here, what I needed really for my 2D platformer was really, this was supposed to be an input. So you input something, and I wanted to make it so if you input anything, it can't be like a really short amount of time and it like breaks everything. The input cannot be like that. So I had to enlarge the input. So this came from that. And basically, if I put one up here, let me find it. I think it's a really interesting and ingenious, because I'm just so smart. Really smart way of doing, like, solving this problem. So we have one of these. If we put one here, basically, instead of running this directly into the thing, we can put it into here, and then put this switch into here, into the thing. This right here is actually two components. The thing I was talking about, I keep on saying thing. this thing that limits the amount of time in a pulse can be. This is actually part of that. This whole like top section right here is that, but this just goes into this logic gate goes into those, and then basically goes into this separate contraption. So that's basically to make it so. This, I mean, one thing about this creation here, which I'll demonstrate this. You know, I can explain stuff more deeply to extend the video a little bit. That's fine. If I take out this whole section right here, which is the kind of limiter thing, and just have a switch that goes into here, then basically what's gonna happen is that's right here is gonna be overloaded, and it's not gonna turn off, and that's can be explained. So let me just explain how this fundamentally works. I'm doing it. I'm explaining this out of order, definitely. So you have this. This is your input. You input a signal into here. And what will happen is that a spud gun will fire into basically the output, basically. Yeah. An output switch. And then that output switch will go into a timer, which will eventually make the spud gun shoot again, turning off the timer. If you know those little box opening things, like you press a button and then something just goes out and like turns it off. Like, actually, you know what, let me do a mini build right now, because that seems fun. I just it's a very simple build here, but just turn a switch, something goes out and just turns it off. It's kind of funny. Yeah, basically it's kind of like that. So what you can do with this is make it so just even if you like do just the tiniest amount of the pulse length, it's fine. It's really just not going to do anything. We'll have a light here to demonstrate. I keep on taking away my tools. This is not going smoothly. Okay. Just a tiny amount. It's going to put out a straight signal. And it's kind of funny how these work, because the only thing that's bad about this is if you do a large enough signal, and then that just makes it always on. And the thing about this right here is doing a short enough signal, because so if you want it to be 4 ticks, then you have to hold it. Make sure you hold it longer than 4 ticks, or else it's going to just like not listen, like not do what you're supposed to do. Because look, I do it just a tiny bit. That is a lot less than 4 ticks. This right there is 4 ticks. That's not, and that could break stuff. So doing anything smaller than the amount of time you want here is bad. Doing anything larger than the time you want here is bad. So you have to put them together, do this. Basically, it extends the time, makes it more visible to the people looking at it and to the computer, so it doesn't just break it. Anyways, this is a more interesting part here, because my creation here has a problem. It is very addicted to alcohol. That's not very funny. Despite the very like how despite that this is a very small pulse length, it can still start when one of these is on and stop when the other is on, meaning that 2 things go on at the same time, which would like just make 2 of these be on at the same time, probably break some stuff, and we don't want that. So what has to happen is that if both these are on, like, so let's just look at these 2. If both these are on, then it's gonna go into here, put out a signal to here, switch the signal, and make it so this one right here it's not if this line right here turns on, it's not just automatically going to be turned on. It also can only be on if this line is off. And this right here is the same. This right here does the same for this. So if this is on and this is off, I mean, if they're both on, then it's going to turn this off. And if these are both on, it's going to turn this off. Meaning that really only one can be on at the same time. And if we look here, that's what happens. Although it only rarely puts two on at the same time. Okay, anyways, that's it. I'll see you in another time, maybe. Bye.